And welcome to ISA's web seminar overview of Foundation Field Bus Technology. Your seminar materials include a downloadable presentation, a question and answer session, and a seminar survey. You earn 1 PDH for attending. Today's seminar is 60 minutes in length. There will be 3 10-minute question and answer sessions. As a participant, you are in a listen-only mode. You may ask questions via the Internet using your keyboard at any time during the presentation. However, the presenter may decide to wait to answer your question until the next Q&A session. If you have audio difficulties, press star 0. Questions may be asked via the telephone line. Press star, then 1 on your telephone keypad to ask a question. If there are no other callers on the line, the operator will announce your question and affiliation to the audience and then take your question. If other participants are asking questions, you will be placed into a queue until you are first in line. While in the queue, you will be on a listen-only mode until the operator indicates that your line has been activated. The operator will announce you by your first and last name and affiliation and then ask for your question. At this time, I would like to give a brief introduction of our speaker. Jonas Berg, educated in Sweden, is a manager at Emerson Process Management in Singapore. He has 20 years of experience in development and application in the field of instrumental and controls. He is one of the architects of Foundation Field Bus. Mr. Berg is a senior member of ISA and president of the Field Bus Foundation Marketing Society in Singapore. Mr. Berg is also the author of the book Field Buses for Process Control, Engineering, Operations, and Maintenance. Mr. Berg received the 1999 ISA Award for Excellence in Documentation. We will now begin today's seminar. Mr. Berg, you may begin.
Welcome to today's presentation. We are glad you could attend and hope the following material will be helpful. Key benefits of today's seminar. Well, you get to know the terminology of field bus so you can better communicate your requirements with vendors and customers. We'll see the benefits and of field bus, so you can justify to project management and get project funding. So we'll look at how you can lower the cost and increase plant output. We'll learn the basics of field bus design. We'll understand what interoperability and device integration is all about. We'll see also how you can integrate field bus with your legacy control system and also field bus on package units. We'll take a look at some of the tools of the trade, that you can use for commissioning and for troubleshooting, if that should be necessary. We'll see how operators also can benefit from field bus. We'll see the new engineering practices or changes to engineering practices, that come about because of field bus. And we'll take a look at how you can leverage device management, to lower operation and maintenance cost. And lastly, we'll look at the constraints and possibilities for better process availability and control safety using field bus. All right, in the first section, we'll begin with an introduction. We will take a look at why technology in general is going digital, and we'll see which communication technology goes where in the plant and the system architecture. We'll see what benefits and savings you can expect so that we can justify the project. We'll take a look at device integration to software, and we'll do the first part of field bus design, that is field bus in a non-hazardous area. Okay, so why do we want to go digital in the first place? Well, digital allows us to reduce the amount of wiring required in the plant, because with Foundation Field Bus, you can put multiple devices on the same pair of wires. In fact, you can put as many as 8 to 12 instruments, on the same pair of wires. Okay. And you can also run multiple signals per device. Okay? If you look at, for example, electrical actuators, okay, they can have as many as 11 signals or more to control them, to open, stop, and close, and overrides, and interlocks, etc. So rather than running 11 pair of wires to an electrical actuator, you can actually hook up several electrical actuators onto a field bus. Digital also gives us better accuracy because you don't lose precision in digital to analog and analog to digital conversion associated with 4 to 20 milliamps. Okay? And, you also eliminate, the differences in current calibration between the transmitter and the receiver, okay? Maybe each conversion, only adds a fraction of a percent of error, but it all adds up, throughout the control loop. If you look at the number of conversions from the transmitters to the input of the controller, to the output of the controller, and then to the positioner, there are a few conversions, and it all adds up, okay? And since transmitters are digital, positioners are digital, control systems are digital, it really doesn't make sense to use analog 4 to 20 milliamp anymore. It should be digital all the way, Digital signals, of course, also have higher integrity because any distortion is detected. If you look at an analog signal, if 18 milliamps for some reason becomes 16 milliamps due to high resistance or a ground loop or something, it's very, very hard to detect because it's still a valid signal. But if a digital signal is distorted, it is very easy to detect that through area checking. Okay. Fieldbus provides more power to the devices. Okay, they are no longer limited by 4 milliamps. They can run on 12 milliamps or more, in fact. So that also allows them to have more powerful diagnostics, since microprocessors can run faster, and you can even create new devices that were not possible before. Communicating using Fieldbus, allows us to get more information from the devices, so we can do device management from the central control room, okay? And we will look at later part of the presentation how intelligent device management allows us to reduce the cost of maintenance and operation. Yeah, Fieldbus enables innovation, okay? Fieldbus have created new classes of instrumentation that never existed before. We have multiple channel temperature transmitters that accept 8 sensors each. We have pump health transmitters, and we have, discrete I/O boxes sitting out in the field. So all of this were not possible before. Fieldbus, gives us alerts, for predictive maintenance. If we have plugged in pulse lines and so on, that gets alerted to the technicians that can look into that, before. For example, the pressure measurement no longer works. Okay? So that can be rectified. Fieldbus communicates all values in engineering unit. Okay, so that means that you can really make full use of transmitters. For the full sensor limit. Okay, so even though maybe only a small range of the transmitters used in normal operation, during abnormal conditions, it could be good, to measure beyond the normal, because, you see what, let's say if the level is higher than normal, etc. You can see that. Okay, you're no longer limited within the calibrated range. Okay? Engineering unit, of course, also eliminates the risk of range mismatch. Okay, there's always a problem if you have a different range calibrated in the transmitter than what you have set in the DCS database, such a mismatch, would cause control and alarms to not work well. Foundation Fieldbus also enables firmware download. Okay, so when new software becomes available for a Fieldbus device, you can actually download new firmware over the bus to that device, and thereby upgrading it to take advantage of the latest diagnostics, etc. So you stave off obsolescence using Fieldbus. Okay. So yeah, there are many reasons for going digital. Next, let's see some basic characteristics of field bus. Well, field bus runs at 31.25 kilobits per second. Okay, and this is a fixed speed. It's not selectable. All field bus devices run at this speed. Okay. Field bus provides bus power, so on the same pair of wires you have both power and communication. In fact, the power is DC and the communication is really looks like an AC signal. Okay, so they actually AC and DC coexist at the same time. Foundation field bus can be used in hazardous areas. There are lots of different solutions out there. I have identified no less than 13 different ways of connecting field bus in hazardous area, and that includes intrinsic safety, non-incentive, increased safety, and of course a flame-proof or explosion-proof. Yeah. Because field bus runs at a moderate speed, the wire can be very long. It can be up to 1.9 kilometers or 1.2 miles, and this is of course very important for connecting field devices such as transmitters and valves, because they are very far away from the control room. Okay, so should always keep in mind that speed and distance always go hand in hand. So if protocols that run faster, they can't run such a long distance. Okay, and the limited speed of field bus also allows us to have spurs. That is shorter wires that branch out from the main bus to the individual devices. We'll take a look at that in the next couple of slides. Anyway, field bus allows you to connect maybe about 6 to 12 devices per bus. Okay, and so yeah, that's where all the wiring savings come from. Field bus is also a international standard. It's an IEC standard, it's a Euro standard, it's even an ANSI standard in the United States. So the fact that it's a standard means that you get interoperability. Devices from different companies, from different vendors can work together with each other. So a transmitter can send a value to a valve positioner of a different brand. Okay, so this device-device communication becomes possible since it's a standard. Okay, and it really gives obviously the user the freedom to choose the brands of equipment that they want to use around the plant. At a higher level in the control system hierarchy, we have the control network. Okay, this is typically based on Ethernet media these days with TCP/IP or UDP/IP. It could be the HSE protocol, the Foundation HSE protocol, but yeah, not so many HSE devices are available. But nevertheless, Ethernet is really the media of choice, for the control network in all modern control systems. At this level, at our control network, we also have redundancy, dual network, which we don't do for field bus. And control network, that's obviously where all the different controllers sit. Also at this point, I want to mention that other buses, there are many. Well, field bus has become a generic term really in the industry, but other buses are not the same as Foundation field bus. There are several differences. Okay, actually, Foundation field bus was specifically designed for process control. Okay, so for example, that includes features like separation of real-time and non-real-time communication. Okay, so there's actually a schedule, that ensures that updates are precisely periodic, and also that the communication is synchronized with the control execution. Okay, so this means that non-essential communication don't interfere with the real-time communication. Okay, and this is actually unique for Foundation field bus. Okay, and it's very, very important to have that for PID control. Okay. Buses which are where the communication is so-called free running are not really suitable for PID control because they are not precisely periodic and they are not synchronized. Okay, that results in too much jitter, etc., which is not good for PID control. So for devices used in PID loops, Foundation field bus is really the protocol of choice. There are some other good features also in Foundation Field Bus. For example, automatic addressing, so you don't need to set address using dip switches. It's all completely automatic, so eliminate human error. And obviously with hundreds or thousands of devices in the plant, it's good that this is automatic, plug and play, so to speak. Foundation Field Bus also allows peer-to-peer communication, okay? So a transmitter can publish a value directly to a valve positioner, so you can even do control in the field. We'll talk more about that. All of the devices on the field bus has a common sense of time because they all have a clock in them, and these clocks are synchronized, okay? This is important for the scheduling I talked about, which is important for PID control, but it also allows all the alarms detected in the devices to be time-stamped, so we get essentially a sequence of event time-stamping at the source, okay? So it becomes more accurate. Okay? And firmware download is also another unique feature of Foundation Field Bus, actually. This next slide here, it really summarizes the differences between the field bus on the one hand and the control network on the other hand, okay? And really what it illustrates is that field bus and Ethernet, for the control network, they really have mutually exclusive characteristics. Each one is good at its thing, And this is why control systems today, they have both field bus and Ethernet. You really need both of these technologies, So that's illustrated by this table. So it's really the points that I talked about earlier on. But you can see the difference here. Next, let's talk about the benefits. For user benefits and owner benefits with field bus, okay? User benefits include, for example, the operators, they get to see not only the value, but also the validity of the value, so they can see if the value is good, bad, or uncertain. So, let's say if there's a sensor failure, the value will be shown, indicated as bad, So the operator, when they see a number and the status is good, they know that they can trust the validity of that measurement. They won't think that, no, that can't be right, that they know that this is right, okay? Similarly, operators also get to see limit information. They get to see if the output, for example, is limited high or low, or if measurement value is held constant, in an override position, for example. So this is very, very useful information to the operator. As far as technicians go, well, they get finer granularity of diagnostics, so they can more accurately pinpoint what the problem is, and so that it's easier for them to do something about it. Technicians also, they can use intelligent device management software, so they can access all their instruments from a single tool, centrally in the control room, or even from a handheld in the field. And this one single tool, they can use to, for all the interaction with the device, being diagnostics or calibration or whatever. So it really makes field bus makes life simpler both for operators and technicians. Okay? Owner benefits really include increased plant output, and it also includes reduced cost. Okay? For example, plants get greater availability because or uptime, or reduced downtime because you can predict faults, faults in the devices. Since the devices have more power, they have more diagnostics, and the Foundation Field Bus has the ability to report problems. Okay, they don't need you to go there with a handle and check if there's a problem. If there's a problem with the Field Bus device, it will tell you. Okay, without you asking. Okay, so problems. First of all, get detected faster if they have already occurred, but also using, for example, statistical process monitoring, that enables me to do plugged impulse line detection and also abnormal situation prevention. If the characteristics of the process are changing, the Field Bus device is able to tell me about it. Field Bus results in higher quality. basically I can eliminate sources of variability. With field bus devices, I can detect wear and tear in valves, for example. I can detect purely tuned devices. Okay, so I can since I can detect this, I can eliminate it. Reduce process variability really means higher quality, higher yield. It allows me to push my set points closer to the optimum, so I also get higher throughput for my plant. Lower maintenance cost comes from really I can reduce preventive maintenance. Instead of preventive maintenance, I can do predictive maintenance. Okay, so I really use diagnostics to see which devices need service. Okay, so I only maintain those devices that need maintenance. I don't spend time on devices that don't need any maintenance. Okay? So these are some of the savings that can be realized and output increases that can be realized with Fieldbus. Okay? Redundancy is something which is deeply ingrained in all of us engineers whenever we talk about communication. We have that drummed into us since young, or since we started our careers, there's got to have to be redundancy. And definitely when you talk about control networks, the Ethernet connecting all the controllers together, then you need it, because it carries a large volume of data, and, it's really shared by the whole system. So it needs redundancy to eliminate single points of failure. But Fieldbus is different. Each Fieldbus, one Fieldbus don't connect all the devices in the plant. One Fieldbus only connect maybe 8 to 12 devices. So in a large plant, you have many Fieldbuses. You could have 100 Fieldbuses running around your plant. Okay, each one handling maybe 8 to 12 devices, or that translates into maybe 1 to 3 control loops per bus. Okay. So this is a very much more decentralized control architecture than on the control network. Okay, so if one bus goes down, it only affects a few loops. Okay, so therefore we don't have redundant wires for Fieldbus. People do have redundant power supplies and often also even redundant interfaces. Okay, but there's only a single pair of wires. Interoperability and device integration. Okay, devices from different suppliers work together, and also software from one supplier can work with devices from many other suppliers. Okay, and device-to-device communication, of course, is possible since all of the devices are using the same protocol. Also should mention that the Fieldbus Foundation, they have a quality assurance system in place, okay, so that the devices and software are tested and verified for compliance. Okay, for devices we have the ITK, Interoperability Test Kit, and for configuration software we have the HIST, Host Interoperability Support Test. Okay. So devices and software that pass this test are given, interoperability check mark. So this is something you want to look for when you buy devices and software. Okay. When it comes to integrating devices to the software, okay, we have part of Fieldbus down in the engine room. It's called Electronic Device Description Language, or EDDL. Okay. So that's really a text file that describes to the configuration software how to interact with the device. Okay, it tells the software how to communicate the data. It tells the software how to decode the information, how to display the information, and there are even methods or scripts in the EDDL that tells the software basically like methods for calibration or advanced setup. Okay, so it really takes the technician through these complicated processes, in a step-by-step manner. Okay, so EDDL is an integral part of Foundation Fieldbus. Okay, and so there's really one EDDL file for every version of every type of device from every manufacturer. Okay. So keep in mind that EDDL is not a driver program. It's more like a web page, really, and the configuration software is almost like a web browser, that allows it to access the information and the functions inside the device. Let's take a look at the design of a regular H1 bus. Okay. Well, first of all, in the control room, okay, you have the controller that also has a interface card, H1 field bus interface card, and also there is a power supply somewhere in the panel. Okay, the power supply, you can't connect 24-volt DC directly to field bus. Okay, you need to have a so-called power conditioner in between. Okay, the reason is that the DC power, well, the power is DC, communication is AC, and you don't want the DC bulk power supply to short circuit the AC communication. So the conditioner is really a power supply impedance. Okay. The main wire going from the control room into the field is called the trunk. It is the one I'm kind of illustrating here with the laser beam. Okay. Then off the trunk, we then have spurs branching out to each individual device. Okay. And these spurs can be up to 120 meters long or 400 feet. Again, this is something fairly unique to field bus, and it makes it very easy to connect these devices in the field. Also note that the trunk is terminated in each end. There's a terminator in the field, and there is a terminator in the control room end. Okay, so two terminators on a bus. Okay, really the purpose of the terminator is not so much to reduce reflections. Is in fact that field bus devices, they transmit by a current signal, but they receive a voltage signal. So the main function of the terminator is really as a shunt, to convert the transmitted current to a voltage that is received by all the other devices. Okay. Obviously, this wiring scheme would also be used if you do a flame-proof installation. You would just run this in trunk inside conduit or using what do you call armored cable. Okay. And there's really lots of different wiring hardware available. Many different suppliers make specific cable for field bus, connectors, junction boxes, and many other things. And later on we'll see different barriers and other things. Lots of different power supplies also available. Different topologies are possible. What I'm illustrating here is what we call a bus topology, but you can also have a tree topology, where basically all of the devices, rather than being distributed along the bus, they all sit in one end. That's what we call the tree topology. We say that you can have 6 to 12 devices per bus. You can have as many as 16 devices per bus in most control systems, but there are other limiting factors. For example, each device consumes power, right? So along the bus, particularly if you have long wires, you get a voltage drop, And since each device needs 9 volt to operate, you simply can't have too long wires because there will be too little voltage available in the field end. Another limiting factor would be the bus cycle time. If you put too many devices on the bus, it just becomes too slow, you would not be able to do, control which is fast enough, For temperature, maybe you can put 16 devices because it's a slow process, but for flow and differential pressure, you're usually very fast, so then you want to reduce the number of devices so you get a fast response. This kind of installation, if you want to do it in Zone 2 or Division 2, really what you do, you have a non-arcing trunk, and then you have current limiters in the junction box, so then you get non-incentive spurs, okay? So this is very popular in North America. About grounding, quite easy. You ground the shield, okay, and you do so in the power supply end, okay? You cannot ground the field bus signal itself, the field bus wires. You always ground only the shield, and only in the power supply end, never at the device, okay? All right, we have come to the end of section 1, so I will go through the key points here. So digital communication has many advantages over analog signals. If your devices are measuring or actuating, as part of a PID loop, really you should use Foundation Field Bus rather than other Field Bus. Field Bus and Ethernet, they complement each other. One is in the field, the other one is the control network. Field Bus suitable for hazardous areas, which is very common in process plant. Field Bus can run very long distance thanks to the moderate speed. Host interoperability is ensured, using electronic device description language. Make sure to buy devices and configuration software which has the registration check mark, to minimize any interoperability problems. Operational savings come from the predictive diagnostics, and intelligent device management software. Obviously, there are also wiring savings and commissioning savings, okay? But these days we try to focus on the savings in the operation phase because it becomes more, okay? So it's question and answer time, so I'm going to turn you over to the operator, Kristen.
If you would like to ask a question, please press star, then the number 1 on your telephone keypad. Once again, that was star, then the number 1 to ask a question. Your first question comes from Jarmo Salmiman with Georgia Pacific.
Hey, Jarmo, I still cannot see whatever on the computer. It's a blank screen. Dennis doesn't see anything either.
I send you the presentation.
Oh, okay. You did. Okay, good. How many repeaters can we have in the Foundation Field Bus?
There can, between any two devices, there can be maximum 4 repeaters.
And there's any deficiencies in terms of high-speed communication for flow or other type of quick information that you can do in the the third or fourth segment? Is there any effects on that speed?
Oh no, the repeater doesn't slow down the communication. Yeah, so it doesn't it doesn't cause any problem, so to speak. The repeaters that we use in Field Bus, they are what we are like. It's like a hub, in Ethernet, so they just cut right through. Okay, they don't have any store and forwards, so no delay is caused by Field Bus repeaters. Okay, so fast loop or slow loop, no problems. You can use repeaters.
You said that there's probably the common practice is you would have about 8 to 12 devices per bus, right?
Yes.
And once you have repeaters, you can add the same amount of devices to each repeaters?
Well, if the thing is next week we have another seminar. We talk a little bit about more the definition, what is a bus and what is a segment, okay? You see, if you take 2 segments and join them together with a repeater, it's still only one bus, okay? And they all use up kind of the same time, so yeah.
Okay, to extend the distance, but the amount of bus and control loops will still remain the same.
Exactly, yeah.
Okay, that makes sense.
Mm.
Now, is there a common practice that you have for a plan that cover the wider area? Common practice you have your controllers installed or resident in your control room, and you have a remote I/O box out in the field. And then you can run your buses from the box to the devices, to the loop.
Well, Field Bus to a certain extent eliminate the need, for traditional remote I/O. Remote I/O is used very much with 4 to 20 million as another way to reduce the wiring.
Yeah.
So it's not really common. I haven't really seen any combination, where people do remote I/O with Foundation Fieldbus, so to speak. As nobody. You could theoretically put some. You could create. There is, in fact, at least one gateway in the market that can be field mounted. And then it runs. Fiber optic Ethernet or something back to the control room. There is such a product, but it's it's more common that people run one field bus all the way from the control room all the way into the field. And then put a bunch of devices on this bus.
For the Foundation Fieldbus considered as a process bus network. For device bus network, for just a discrete communication, you still can use Foundation Fieldbus for discrete communication. But is there a gateway between Foundation Fieldbus and for example, ASI bus?
No, but between these two protocols. Nothing that I'm aware of. There are some a few suppliers in the market that make small little boxes that handle maybe 8 or 16 discrete I/O. Okay, and they sit on the H1 Fieldbus. That in fact exists. But often what happens you find that for example proximity switches and limit switches and these things, these small products, they don't use Foundation Fieldbus. They use ASI bus, and so they simply run on a different bus and that lands on a different interface card in the control system.
Yeah, I just wondering for example, like Honeywell controllers, you don't have direct communication with ASI bus. That's where you have to have a gateway to communicate with that via, for example, like Profibus. Is that common practice?
Yeah, well, I think most common is that the control system, in fact, have an interface card for ASI. But what is in the common practice is to not really put discrete signals on Foundation Fieldbus. Foundation Fieldbus is really best suited for PID type of loops, and those transmitters. You can put some discrete on it too, but really those large volumes of discrete I/O, people normally don't put on H1 Fieldbus.
Yeah, I understood that. I just want to find out, is there anyone doing that out there, or is there any common practice that they do that?
I've seen some instances of people putting those small I/O boxes on Fieldbus. I have seen that. Yeah.
Yeah, understood.
And I've also separate bus for discrete.
And they don't experience any, they not encounter any problems or communication problems or any difficulties in the way that how they set it up.
No, I think it's not very common, So even on the internet, no one has mentioned anything to me, and I haven't really seen it on the internet forums either, which is where people really come clean with this sort of problems, So, yeah.
Somebody else can have questions.
Once again, to ask a question, please press star then the number 1. Your next question comes from Joan Arbor with San Diego ISA.
My question is about the distance of 1.9 kilometers or 1.2 miles. Is that just the distance from the controller to the final terminator, or does that include the spurs?
That includes everything, all the trunk and all the spurs and everything total up. Is, yeah.
Okay, thank you.
Yeah.
Okay, there are no further questions at this time.
All right. Some really good questions there. Thank you very much. Really makes the whole thing so much more interesting. Okay, we'll push on through with section 2. We'll take a look at hazardous area bus design, high power trunk concept, a little bit on commissioning devices, configuring parameters in the devices, a little bit about system integration, particularly with legacy DCS and package units, and a little bit on troubleshooting and what are the tools of the trade available, at your disposal to fix problems. Yeah. Right. In intrinsically safe bus, okay. Essentially, instead of using the power conditioner I talked about before, you replace that with a barrier instead when you want to do intrinsic safety. Okay, so barrier goes in place of really goes in place of the conditioner. Yeah. So these barriers, there are barriers in the market that can also be field mounted. We will see that in the next slide. Okay. And you should keep in mind that you need to use special field bus barriers. You can't just use any field bus barrier, okay? And the number of devices that can connect to one barrier really depends on how much power this barrier makes available, okay? So that, again, in turn depends on the design of the barrier, which gas group it was designed for, and it also depends on the power consumption of the devices, obviously, okay? Typically, okay, if you refer to the table there, for EXIA, in intrinsic safety, with up to 2 volts. In gas group 2C, I have 1.9 watts available. Okay, so considering a normal device power consumption of maybe 20 milliamps, most devices have less these days, but some of them have a little bit more. But typically, that would give me about 5 devices on such a barrier. Okay. However, there are a few different solutions available in the market. One of them is that you can connect several barriers together, like illustrated in this figure. So that way you could still have several devices on a bus. You have multiple segment creating one big field bus, with several devices on it. Now, if we instead can use EXIB design, we have 2.5 watts. So that allows me to put 8 devices per barrier. And if I can use gas group 2B, or C, as you call it in North America, I have as much as 5.3 watts of power available. So then I can connect no less than 13 devices on one barrier. And that's about all you would really need, okay? So next, we'll take a look at the high power trunk concept, okay? So really what you're doing is you'd have a non-intrinsically safe trunk, okay, and that way you can put many more devices on the bus, okay, simply by moving the barrier into the field, okay. Let's take a look at what that looks like, okay. Right. What you're seeing here, okay, is that the devices can still be in Zone 1 or Zone 0, or, Division 1, as you call it in North America. So down here in the field, we still use intrinsic safety, but the barrier is now sitting inside the junction box inside the field. Okay, so I have an increased safety trunk, a high power trunk that runs in. That can also run in Zone 1 and Division 1. Okay. Okay, so I have, so if I use a field-mounted barrier, I have an EXE, increased safety trunk, with intrinsically safe spur. I can also use this in Zone 2 if I like. Okay, in that case, I would have a non-arcing or non-sparking trunk and a non-incentive spurs. Okay, so that's a solution ideal for Zone 2. okay, both intrinsic safety and non-incentive allows me to do live work on these spurs. Okay, so I can remove and connect devices live, which is very good for maintenance, obviously. However, with those, I cannot do live work on the trunk. Okay, I still can if I do, if I got a hot work permit and I do gas sniffing and all of that, but maybe not so convenient. Yeah. The beauty here, okay, is that most maintenances are associated with the devices, and it's done on the spurs without even touching the trunk. So not much worry there. Another beauty here, okay, is that I can still use redundant power supplies. Okay, I cannot have redundant safety barriers, but I can have redundant power supplies and power conditioners. Okay. Another thing, okay, is that this way I only connect one device per spur, and a lot of people feel good about that because if I create a short circuit on one of the spurs, that spur is current limited so that it doesn't affect the other devices on this bus. Okay, it only affects that one device. Okay, so it's an availability issue there also that this one. So this solution solves quite a lot of things, in fact. Okay. So since I have a high power trunk, I can run long distance, and I can have many devices. Okay, I can have as many as 16 devices on one bus using this solution, no problem. A little bit on commissioning devices. The EDDL files that I talked about earlier, they are usually, a lot of them are already loaded on the computer. When I buy my Fieldbus system with intelligent device management software, support files for all the devices existing in the market are typically already loaded. But of course, as years go by, and I replace devices, I add new devices as part of extensions, etc., there will be new brands, new models, new versions coming in, into my system. And then what I do is I just I download these EDDL files from the internet and just copy them into the folders, of my system. And, presto, these devices are now supported, okay? Commissioning Fieldbus devices is actually quite simple, and this is really commissioning is one point where you can have considerable CapEx savings with Fieldbus. Not only the wiring reduction, but the fact that commissioning devices can actually be a lot faster. If you buy your Fieldbus devices with a tag pre-assigned by the factory, when this device is hooked up onto the Fieldbus, it gets automatically detected by the system, and basically it commissions itself by the system. So you can commission a device maybe in 20 minutes or less with one guy, as compared to two guys working an hour or two, as it would be the case with 4 to 20 milliamp, when you need to radio each other with walkie-talkie, etc., to bring out the wires. Okay. So yeah, when I hook up the device, it's automatically identified and detected, obviously, and assigned an address. Okay, and it automatically becomes bound to the placeholder in the control system. Now, if you buy the device without the tag assigned, it becomes a little bit more complex, okay? Because when you hook up the device, the system doesn't know where that device belongs, okay? Each device that communicates Fieldbus has a unique device ID, okay? It's like a social security number, really. It consists of the manufacturer code, device type code, and the serial number. Okay, and that's unique in the world. So really, the way when you want to commission a device, you need to bind that device ID to the tag. And the way that this is done, if it's not done automatically, all the new devices, they typically get shipped with a paper slip attached to it. Okay, this is called a commissioning tag, but people call them like a dog tag. So, and this dog tag has the device ID on it. So when the guy installs the device, he writes the tag on this dog tag and carry it off and bring it back with him into the control room. So on this tag now, he has both the device ID and the tag. So it's very easy to pick the device ID from a drop-down list in the system. and you know, and presto, you get the device is commissioned. Okay, quite easy. And most control systems today, or the good ones at least, have you know, wizards, you know, for commissioning devices and replacing devices. Okay? The screen here really shows the top one shows how these device description files are logically organized on your hard disk, and the bottom screen really shows a so-called live list. It's really a list in the system that shows you all of the devices on each bus. And so you can see which ones are communicating. You can see their tag, you can see the unique ID, and you can see the address that have been automatically assigned by the system. Okay. So if a device doesn't show up in this list, it either means it has not been connected, or, well, connected to the wrong bus, or there is something seriously wrong with the device. Okay. So anytime a device stops communicating, it drops out of this list. Anytime you connect a new device to the bus, it shows up in this list. Okay, so it's a very useful troubleshooting tool, very useful for commissioning. So this live list really takes the place of the traditional ringing out of wires. Okay. Device configuration, or parameterization as we call it sometimes, that's really done primarily in the so-called transducer blocks. Okay. Devices each device has one resource block, where you get all the information about the device, such as who's the manufacturer, what is the overall health of the device, model, version, etc. The transducer block is where you configure the sensors and the actuators. So so depending on the device type, you will have a different transducer block. A pressure transmitter has a pressure transducer block. Temperature transmitter has a temperature transducer block. A valve positioner has a positioner transducer block. Okay. So this is where you can perform all the calibration as well. Most of the diagnostics is found here. You do valve performance analysis. You get operational statistics on how many times the valve has opened and closed and how much has traveled, etc. All of this stuff is inside the transducer block, okay? And you really use the same configuration tool to configure the devices, to configure the field bus, and to build a control strategy, okay? All of this is done from the same tool, really. So it becomes quite easy, you know, as compared to in the past where you configured the control system using one software and then you had to use a handheld to configure the device. That's no more. All can now be done in the same single tool. Like we talked a little bit in the question and answer session, okay? Foundation field bus is really super for PID regulatory type of control, okay? But there's no variable speed drive using foundation field bus. Okay, so if you have variable speed drives in your plant, you have to connect them some other way. For example, using Profibus DP or DeviceNet. Okay, same thing. If you have lots of switches, you know, proximity switches, you know, lights, pilot lamps, etc. These guys don't talk foundation field bus either. So typically that would be done using DeviceNet or ASI bus. Okay, so really in the control system you have the need to bring together different field bus technologies. Okay. One way to do this is using HSC in the future, but there are not really many devices available with HSC in the market as yet. However, you know, the control system you buy, it can have interface cards for the different communication protocols. Okay. Package unit integration. Okay. Well, typically in the past, a package unit would have a PLC on it, and then you would, you know, maybe use Modbus or something, you know, to integrate it. Okay. That's still possible with Fieldbus. In fact, there is like a Fieldbus interface module or a gateway between Foundation Fieldbus or Modbus. That's really the only gateway between Fieldbus and another protocol that I'm aware of. Okay. So this Fieldbus interface module, it can mount on the package unit, and you know, it can then bring together the different devices, Fieldbus devices on this package unit, you know, create the links, you know, to form the control loops, etc. And it makes data available as Modbus. Okay, so if, let's say, even if the main control system doesn't support Fieldbus, you can use this Fieldbus interface module to convert all the information to Modbus. So it can even become accessible to legacy control system. Okay, so Fieldbus can actually coexist with the existing system. And the configuration of the devices and the control strategy on Fieldbus can really be done using an embedded web browser, using HTTP protocol. And device management of Fieldbus can in fact be done using the HSE bus going up to the intelligent device management software. Okay. This might also be a good way for you guys to evaluate Fieldbus technology. You can start small with maybe just a few devices somewhere on a non-critical portion of your plant to see for yourself how Fieldbus works and what you can do with it. Okay. Okay. What are the tools of the trade that's available? Okay. Well, first of all, the engineering tools which are built into control systems that support Fieldbus have several diagnostic functions. Most important is the live list that I talked about, but other useful information is communication statistics. Okay, you can click on the port icon in the software. You can see how many, or you can see what is the error rate, what is the percentage of communication failures on the bus. If that's anywhere above 1%, you know that you have a serious problem. Okay. And you need to fix it. If it's low, then the bus is working all right. So this is good diagnostics to have available in the system. Okay, and really, Fieldbus systems, they give a very clear indication if there's any communication failures. Okay, so it doesn't go undetected. Beauty with communication is very easy to diagnose. So you immediately detect problems if there's any. And there's lots of parameters in the Fieldbus devices that allows you to debug the control strategy and see the health of the devices, mode parameters, error parameters, etc. that you can look at. In the market, like shown in the picture there's even specialized testers available that can check the bus voltage, if all the terminators are present, signal level, noise level, count number of the devices, etc. Also, the Fieldbus handheld communicator can give you this information. Okay, so a lot of powerful tools out there in the market. Okay, we've come to the end of section 2. Let's review the key points. Well, you can get tools which integrate, the bus configuration with the device parameterization and the control strategy programming. We'll talk about programming control strategy in the next section. It's possible to integrate Fieldbus with legacy control systems and also with package units and other buses. Invest early in troubleshooting tools, so that while commissioning your Fieldbus system, if you have any trouble, you already have all the tools in place to solve the problems. Keep in mind that there are many solutions out there for running Fieldbus in hazardous areas. You can have a regular installation, you can have an explosion-proof installation. You can use intrinsic safety. You can use a combination of increased safety and intrinsic safety. You can use a combination of non-arcing and non-incentive. Okay, so lots of different ways of running Fieldbus in hazardous areas. Okay, it's question and answer time again. I'm going to turn you over to the operator, Kristen.
At this time, if you would like to ask a question, please press star, then the number 1 on your telephone keypad. Once again, that was star, then the number 1 to ask a question. Your first question comes from Yarmo Salmimi with Georgia Pacific.
Go ahead.
Go ahead.
Yarmo, your line is open.
Yeah, for analytical instruments, inline analytical instrument, is that common practice to use Foundation Fieldbus to not just monitoring but also controls, adding in your control loop?
Yeah, there are. I'm familiar, for example, with the pH transmitters, conductivity transmitters, and even like flue gas analyzers. these are very often used, with Foundation Fieldbus. Yeah. Is that the kind of analyzers you're looking at, or there are even some gas chromatographs and BTU analyzers? Those I haven't seen that many, but I know they do exist. Yeah.
Well, I used Modbus before with inline near-infrared, but never had any analytical instrument with Foundation Fieldbus. I don't know how well does it work.
Yeah. Well, the inline infrared, I'm not familiar with those type of analyzers. I know with like pH and conductivity and flue gas, etc., it really works excellent, and a lot of people have been using Modbus for those in the past, but as you know, the problem with Modbus, okay, is that everything maps into registers, okay? Every parameter goes into one register, and then inside your PLC or HMI, you have to kind of unravel those registers back into the data, and that's of course a lot of work. And if you make modifications, you have to update your documentation. It's a real hassle. The beauty with Foundation Fieldbus over Modbus, okay, is that information is organized in those transducer blocks and function blocks I'm talking about, and all parameters have, well, more or less human-readable names, and with the EDDL, all of the, that contains human-readable labels, etc., so I never have to look at, numbered registers. I never have to ask myself, what data type is this? Is the least significant byte first or last? All of these hassles you have with Modbus kind of go away with Fieldbus, so it will probably be a good move,
Okay, that's the second. Another question I have is for example, you said P90 loop control is very common practice with Foundation Fieldbus. Is that is that extended to like model predictive control as well with let's say using IMC, internal model control base for all that loops as well?
Absolutely. Obviously, those type of software typically run on a workstation, right? They don't run in the Fieldbus devices themselves, but they do sit in the higher level software, and they use the underlying Fieldbus, for the inputs and outputs, really, yeah.
Okay.
Yeah.
Okay. So there's no problem with the communication. That's my concern.
Yeah, no problems at all. In fact, Fieldbus really goes very, very well together with this kind of model predictive control for a number of reasons. First of all, using Fieldbus, it becomes so much easier to bring in more measurement points, okay? And secondly, the fact that many of these model predictive control strategies, okay, if there is, let's say, a sensor failure, you're passing, traditionally you would be passing invalid data into your model predictive control loop, okay? And that would kind of upset your model, and you would have all kinds of problems. The beauty with Fieldbus, okay, is that, diagnostics is passed along with every update of the information. So if there's a sensor failure, the model predictive software gets informed of it, and it stops adapting the model according to the invalid data. I don't know if I managed to explain that really well or not, but yeah, it's a really good combination. Yeah.
Last question is the communication connection means. Is it common practice we use Turk components to connect Foundation Fieldbus?
You're talking about those quick connectors?
Connectors.
Yeah.
Conjunctions?
No, not really. It's not really the norm. There are lots and lots of different hardware which people use. Like the beauty with Fieldbus, okay, is that because of the moderate speed, you don't need to have specialized connectors. Normal screw terminals, works well. There's some merit to the Turk quick connectors. It makes it easier to disconnect the device, make a clean disconnect, and so on. But devices these days, they are so reliable, they don't really fail. They're so stable, you don't have to calibrate them that often. So there's really not that much need for you to go and disconnect the device in the first place. So. I find that it's not that common to use it,
Thank you.
Yeah.
I yield for somebody else.
Yep.
Once again, please press star 1 to ask a question. The next question comes from Joan Auber with San Diego ISA.
I have a question about the integration of PLCs. You said that it makes it easy when you use field devices to integrate perhaps PLCs into your system too. Can you talk about that a little bit more?
Okay. Well, I can't remember which slide that was, but obviously there are some PLCs in the market that have so-called linking devices, that makes it possible to integrate field bus into the PLC. So a linking device is like a box that sits on the same control network as the PLC itself. And then the PLC can somehow exchange data with this linking device. I don't know if that answers your question. Yeah.
Okay.
It's not hardware that sits in the RAM. It sits on it can sit on the data highway.
Once again, please press star 1 to ask a question. And there are no questions at this time.
Okay, we will move on with section 3. So I will talk a little bit about engineering and design. How the engineering practices change. Different drawings, maybe different standards. We'll talk about maintenance and device management, how you can leverage predictive device diagnostics and device management software for more effective maintenance scheduling. We'll talk about changing your work practices accordingly to really benefit from Fieldbus. We'll talk about the function block diagram programming language as promised, and we'll see how the basic process control systems availability and safety can benefit from Fieldbus. Okay, how you can make control system layer more fault tolerant and safer. Okay, essential document for any control system is the P&I diagram, obviously. And well, the most common question on the P&I diagram is, how do I draw Fieldbus? What does Fieldbus look like on a P&I diagram? And really, last time I checked, ISA had not really changed their standard, but what we're seeing in the market, okay, and it's not really clear from this slide here, but if you look at the line with a dot, dash dot dash line on top, okay, so the proposed symbol for Fieldbus is a filled dot, okay, whereas the internal DCS data link symbol is like an empty circle. It doesn't really look empty there on the screen, but believe me, it's empty, okay? So that's really how you differentiate between DCS data link signal and Fieldbus data link signal, okay? Is that the fact that the Fieldbus signal is filled. Another thing that people fret over, okay, is that, okay, if I do control in the field and I have the PID, etc., how do I show where the PID is located? Well, one way of doing it, okay, is that, let's say the PID is done in the valve positioner, which is probably the most common way of doing it. Well, you simply draw the PID block or the PID bubble adjacent to the valve positioner bubble. So that way you kind of intuitively understand that the PID is kind of together with the valve positioner, okay? So yeah, keep in mind, okay, that when in a P&I diagram, okay, really you want to show data flow, okay? You don't want to show the physical bus wiring, okay? then it becomes too cluttered if you try to mix field bus wiring in the P&I diagram. So yeah, stay away from that, okay? Another interesting thing, okay, is that for a traditional 4 to 20 milliamp wiring, we used to have a instrument loop diagram, right? For every loop or every measurement point, we had an instrument loop diagram. Field bus, really, this becomes replaced by a segment drawing or a bus drawing, okay? So this, well, first thing that happens, okay, is that in one drawing, it shows me all maybe 16 devices or 8 or 12 devices, whatever I have on my bus. All of those shows up on the same drawing. Well, this is, of course, important from the standpoint that if I'm touching one device, I want to know maybe what other devices are on the same bus, you know, so that essentially the technician knows how careful they have to be, you know, because now they can see that this wire, if I disconnect this wire, it might affect 16 devices, not just one, you know, so that's an important thing to illustrate, okay. Another important fact comes out of this, okay, and that is that I can have one segment drawing now replacing up to 16 instrument loop diagram, okay, so it can actually reduce not only the hardware and all the wires associated with field bus and the cable trays and the ladders and all of that. Field bus also reduces the amount of drawings and the engineering work as well, okay, so that's another CapEx saving or capital expenditure reduction that comes out of field bus. Okay. I have said in the presentation the word device management many times. Okay, what is device management? Well, field bus brings me a lot more information. Well, what information does field bus give me, and what on earth do I use this information for? Well, field bus brings me identification information such as device tag, the device ID that we talked about, tells me who is the manufacturer, what is the serial number and the version of that device. General information such as materials of construction, you know, let's say my pressure transmitter, what diaphragm material, is it stainless steel, Hastelloy, or tantalum, what flange materials do I have, what is the process connection, and all of that information is of course useful if I need to replace device, let's say, you know, then I can easily get a new device, you know, because whatever information is available inside the device is always much more up to date than the information that I might have on some document stashed away in a drawer somewhere. I have live diagnostics from the device. I have ability to do performance analysis, capture valve signature and step response, you know, to see the health of my valves. Operational statistics, you know, valve positioners commonly count the reversals and the total travel, you know, which is of course an estimate of the wear and tear on the valve, which are then used for predictive maintenance. I can do, you know, configuration or parameterization of the device. I can change the range. I can reconcile the configuration of the device against my database, you know, to see that when I connect a new device, I can make sure that it's properly configured. I can do simulation and override. I can essentially make a loop test, you know, with a field bus device. I can simulate a high pressure or a high temperature to make sure that all my interlocks are working okay. Calibration trim, you know, to correct for drift is possible. I can check on device security, if the right protection is on in my devices, etc. The device ID is also used for a lot of other functions in an intelligent device management software. For example, based on the device ID, I can tell who is the manufacturer and what type of device do I have. And based on this, the software can then pull up at the click of a button the correct manual for the device, let's say, or instruction sheet for performing calibration or some other function. Okay, and of course the same software can pull up information about the plant location, such as the hookup drawing, etc. Okay, I can do online monitoring to see the online dynamic parameters inside the device, so I can tell why the device is operating the way it is and figure out why it's not doing what I want it to do. Based on device ID, I can also do maintenance log, all the maintenance, that inspection that's been carried out on that particular device. And it gets tracked throughout the life of the device regardless of where it's installed. Service notes, I can put in audit trail, all the changes that have been made to this device, which is of course good for certain industries which requires this to be documented. I can easily pull up a list of all the instruments in my entire plant to see my installed base. Could be good for a certain decision making. Based on the results of diagnostics and so on, I can schedule my maintenance. Okay. Once, if I have a failure or impending failure, I can schedule maintenance for that device. If I see that the performance of a device is degrading, I can schedule a calibration for that device in my Intelligent Device Management software. Oh, obviously I can reset the misbehaving device. I can upgrade the device by downloading new firmware, etc. And I can, obviously the Intelligent Device Management software also for commissioning devices. Okay. So once I put my Fieldbus infrastructure in place, there's a lot of stuff I can do with this device. Okay. But if I don't have Fieldbus, you can't really get all of the functionality out of the devices which are available in the market today. Well, a few more words on diagnostics. So really, a Fieldbus system is permanently communicating. Okay, it's not like in the past where you have a handheld, you had to kind of go out and hook up the handheld to the device to see if it's working. Okay, with Fieldbus, the handheld is still available, but since Fieldbus is communicating all the time, if there's a problem, the device tells me immediately, and and the information shows up on the screen for the technician, that can then take action immediately. And the information, it pinpoints the problem, and that of course makes the faster to repair the device. Okay? I have actionable information. It tells the technician what to do. Not only that there's a problem, but it tells the technician what to do. So that improves my availability of the whole system. Okay, I eliminate unnecessary preventive maintenance. So I don't spend resources on devices which are okay. I just work on the devices that really needs my attention. Okay, based on the actual condition of the device. Operational statistics allows me to predict failure. Okay, I can estimate remaining service life. Okay, this is how it works. Okay, the valve manufacturer may tell me that I need to replace the stem packing every 100,000 reversals. So then I key in a limit of 90,000 in my positioner. Okay, so after 90,000 reversals, positioner tells me it's time to get the spare parts and schedule maintenance. Okay, so then I can fix this stem packing before it fails, and I don't do it unnecessarily early. Okay, so that's one good point. Okay, so really I lower my maintenance cost by not doing unnecessary maintenance. Okay, and I can schedule maintenance much better. So I can do all of these devices in need of maintenance in one go, okay, in a maintenance campaign, okay? So it allows me to reduce the downtime, and this also, of course, makes the plants safer, which is also very important. Okay, function block diagram language, okay, so the Foundation Fieldbus standard really contains these visual programming language for building control strategy based on IEC 61804-2. Okay, so there are different kinds of function blocks: analog input, analog output, PID, etc., alarm blocks, arithmetic blocks, signal selectors, and God knows what. And really, I build my control strategy by linking these blocks together. And this can even be decentralized in the field. Okay, transmitters always have analog input blocks. Valve positioners always have analog output blocks. But the positioner can also have a PID block. So as you can see from this slide, I have built a control loop consisting only of the transmitter and the positioner. there's no centralized controller involved, okay? So it's a completely decentralized control strategy. Now this works, and this works very well, okay? And most field bus installation use this scheme, okay? Not for maybe 80% of all the control loops, you know? Not 100%, but 80% of the loops maybe use this scheme. So in these function blocks, I then have standardized parameters for process value, set point, mode, etc. Okay, and another unique thing is that they have status for shutdown. Okay, so this status gets propagated from end to end, from the transmitter to the valve. Okay, there's a slide towards the end that will show that. Pardon me. Well, I'm running out of voice, but there are only a few more slides to go. Okay, so field bus enables control in the field. Okay, CIF, that's another 3-letter acronym for you. Well, what are the advantages of control in the field? Well, if you compare the 3 loops here, okay, if I put the PID in the valve positioner, I only need to communicate one bus over the field bus. That is from the transmitter. There's a process value going from the transmitter to the valve positioner. Only one communicated real-time value. If I put the PID in the transmitter, as you can see from the second diagram, I get 2 values communicated across the field bus. There's output of the PID and the actual valve position feedback. If I were to put the PID in a centralized controller, which is completely possible and a lot of people do it, then I need to communicate 3 links across the field bus. PV from the transmitter to the controller, output from the controller to the valve, and the actual valve position from the valve to the controller. Now what happens here, okay, is that each communication link takes 30 milliseconds, okay? So you will find that doing control in the controller is in fact slower than doing control in the field, okay? So, and this holds truth for simple control strategies. If I get a really funky control strategy, including a lot of function blocks, then it becomes better to do it in the centralized controller. Also, if I have interlocks involving other buses, such as Profibus or discrete hardware, then again, it also makes sense to do it in the controller. So you will find that maybe 20% of your loops remain in the centralized controller and about 80% of the loops go into the field, okay? Now, when we do talk about field bus, okay, there are a few differences in the way things are done around the plant that we need to tackle. This is at engineering stage, okay, and also during the operation stage. So when you move to field bus, you want to look at your work processes, okay? To really benefit from field bus, you need to change your work practices, you know, in the plant to benefit from predictive diagnostics. If you put in field bus and you don't use intelligent device management, if you don't use the diagnostics to schedule your maintenance, field bus will not bring you all the savings which are possible. You will get the wiring savings, but you won't get the operation savings, okay? If you want to do control in the field, or if you want to do field bus in general, you have to change your engineering standards, you know, and your forms and the documentation that you use in the plant in order to make sure you get a good field bus solution, okay? And changing your engineering practices, developing the proper engineering standards, that really makes the difference between success and failure for a field bus system, okay? Now, reputable vendors in the land of field bus, they have consultants that can help you make this, okay? They can change your work practices, they can change your engineering standards, they can work with you to do that, okay? So this is not difficult, okay? But it should be done before you get started on your field bus project, okay? You also need to look at what is the boundary between system and instruments, okay? Traditionally, you have system engineer and you have instrument engineers. Well, when you do control in the field, you know, this boundary becomes blurred, okay? Because transmitters are now so integrated to the system that they really become one and the same, okay? So you can't really have 2 separate teams anymore, you know? It really becomes one system set of guys, okay? You want to look at how do you deal with management of change in the field bus world in order to maintain the integrity of your system, okay? And if you're doing a project, you need to build your internal skills within your own company, within your EPC contractor, and the installation people, okay? Other contractors, that you use for the project, okay? Of course, you guys which are on the ISA course right now, you have done the right first step, but all your subcontractors need to do the same thing. They need to build competence in field bus, for the project to be a real success. Okay, let's talk about availability and safety for a moment. Okay, let me first state straight out, okay, that foundation field bus are not used in safety instrumented systems yet, okay? There's work being done to make field bus suitable for safety systems, but that's not yet, okay? So right now what I'm talking about is the basic process control system layer in your, and I'm talking about the availability and safety of the basic process control system, not about any SIS at this stage, okay? Field bus have plenty of diagnostics and fault detection. So you have, for example, if there's a sensor failure, a device failure, or communication failure, I get a bad status. And this gets propagated through the function block from the transmitters, put the PID in manual, and that brings the valve positioner to a fail-safe state, okay? And all these interlocks are built in the function blocks. I don't need to configure them. It's already there for you to use. Very easy. So this is really one of my favorite features of field bus. Okay? So, and in these function blocks, there are lots of options that you can configure how to balance, safety and availability. Do you want it to, in case there's a communication failure, do you want it to fail safe, or do you want to remain in the last position, etc.? And once communication recovers, should control continue or recover, or should it remain shut down, etc.? Lots of options, okay? Another thing, okay, is that usually you have redundant interface cards, okay, for field bus, at least for the buses with control. If there's a pure monitoring segment, then maybe you only have a single interface card. And many people, they only use single interface card, even for control, because it's really not that much that can fail. And then instead of having a redundant interface card, what they do is that they put a backup link active scheduler, backup LAS, link active scheduler, in one or more of the field devices. So what happens is, if the interface card fails, as long as you have power supply, control in the field can continue, okay, uninterrupted, okay? So you get great availability even without redundant interface cards. That's a pretty neat feature, okay? So we have come to the end of section 3. So a review of the key points. So there are some changes to the engineering documents and the standards, that you should do before, when you embark on the project. You should change your operation and maintenance practices to really benefit from field bus. Field bus includes a standard programming language for building control strategies. And you should make sure that your control system is using this function blocks also in the centralized controller. In case, when you do centralized control, you want to use the same language in the controller as in the field devices. You don't want to have two different languages in your system. Okay? And field bus give you a lot of new options for availability and safety in your basic process control system layer. Right. Okay. So it's time for the last question and answer sessions. Okay. So now you can post any final question, not only on the section 3, but the entire presentation. Any question, okay, that you still have in your head. And I'm going to turn you over to the operator, Kristen.
Okay. At this time, if you would like to ask a question, please press star then the number 1 on your telephone keypad. First question comes from Jamar Salmiman with Georgia Pacific.
My question is, for one that doesn't have any experience on foundation field bus, in order for that person to able to let's say do all the tasks on the, for example, on the device management overview, how many trainings that one needs to have?
Well, how many training?
Oh,
to be honest, I don't really know how to answer this question. I know for let's say we're talking about the device management software, for example. I think each device management software vendor have like kind of customized courses for their software, you know. And well, in my daytime job, I work obviously for Emerson Process Management, and they have such a software, and there's courses for it. But I really don't know how long it is. It's a couple of days, I think.
Okay. So there's a course that offered to help out with this.
Yeah, and next week on the 18th, I'm also running another WebEx, you know, on which talks more about design and installation of, you know, of field bus, you know, about power supplies and repeaters and power conditioners, and more about the intrinsic safety, etc. You know, that's also very useful information, you know, for you to get started. Yeah.
Yeah. Second question is, I have done in the past some manual segment and topology design, you know, just manual to make sure that for the network communication network that does not violate or any deficiency in that. Is there any software like you can check the segment that you designed?
Yeah, absolutely. This is one thing I'm going to talk about next week. Definitely, there are so-called segment design tool softwares out there in the market that makes it easier to. I mean, I talked about the constraints in the earlier slides, right? That each different devices have different power consumption, different wiring solutions have different amount of power available, okay? And so there are tools out there that already contain the information of, you know, about leading power supply or power conditioner parts in the market and different field bus instruments available in the market. So you drag and drop these devices onto your drawing and wire them up, and it will calculate for you basically how much power you have available on the terminal of each device, you know, and it creates a little report for you that tells you if any of the field bus limits are being violated, if you have too much total wire, too much voltage drop, too long spurs, too many terminators and stuff like that, yeah.
Yeah, range and checks on that, or make it how it fit.
Yeah, you have to key in. The main information you need to key in is the length of the wires in your plant. Basically, all other information is in the software already. Yeah. So, but you need to know how long each cable section is. You know.
Yeah. Okay. So what you're saying is Foundation Field Bus does not have that software. Somebody else?
No, but it's a few different you know, vendors. You know, obviously my employer has one that you can download on their website for free, and I know like some of the barrier suppliers also have tools, you know, which are kind of specifically geared towards their way of doing things. You know, yeah.
I'm just thinking about realistic when one approaches this kind of work, and when one walk outside, check out the devices, and then where your controller is, and go back in the table and try to line up all that segment and topologies.
Yeah. Well, basically, this segment design is something that you should do way, way, way before you actually install things into the field. You know. So this is an engineering stage tool. You know, it's as part of the detailed design. Once you have done that, you know, you won't really use this tool again. You know.
Okay.
Yeah.
Thank you. I yield for somebody else.
Your next question comes from Rahaven de Araman with AES Corporation.
Good morning. This is actually David Garrels, and I've got a question on, with the PID loop embedded in the valve, are there ones with auto-tune available?
Yes, there are. Basically, and there are a few different ways of doing it. Basically the auto-tune is some PIDs, they do the auto-tuning in the valve positioner itself, which is probably the best way of doing it. Other solutions include, for example, where the software that sits somewhere above monitors the block in the device and then draws the conclusion from there. So yeah, even if you do PID in the field, you still have auto-tuning and all those nice features, okay? Good point also that I should mention is that as far as the operator is concerned, they don't even know where the PID sits, because the faceplates on the DCS screens and the MMIC graphics look identical to what they're doing today, They can't tell where the PID is located. It's totally transparent.
Okay. Thank you.
Welcome.
Once again, please press star 1 to ask a question. Again, that was star 1 to ask a question at this time. Okay, there are no questions.
Okay. Well, next, I would like you to highlight to us how many of you are on each side, at each site, so that we get an idea of how many of you are tuning in today. So I'll give you a couple of seconds. Or could you please just click on the screen there, and let me know how many of you are out there. I see. I think there's still 2 of you out there that haven't clicked yet. If you could go ahead and do that, it'd be super. Yeah. Yeah. Oh, okay. All right. Anyway, let's move on. I'll talk to you about some of the related courses available and stuff from our SA. We have the full-fledged course, Overview of Foundation Field Bus Technology. ISA can essentially come to you, or you can come to ISA and do this course. Well, if you don't know which bus to go for in the first place, there's another course, Picking the Right Bus, that you could take. And there's also one on the very, very basics on industrial data communication. All this available from ISA, obviously. Other stuff, it's my book. This training is based on that book, Field Buses for Process Control, Engineering, Operation, and Maintenance. Okay. And of course, there is the Field Bus Standard. It's not really suitable for end users. It's more standards really for those that want to develop products. Okay. As an end user, you're probably better off reading my book, where the standards have been converted to human readable English language. Yeah? And obviously, as an ISA member, you should be an ISA member to begin with. And if you're already an ISA member, you can, of course, also join the different divisions, where you can get more information on that. ISA has several certified courses, so that you can, have some credentials, certified automation professional, certified control system technician, certified industrial maintenance mechanic. Okay, last seminar survey, if you could help us with that. Okay. So this is a tool that helps ISA maintain the quality of training programs, so feedback is very welcome. So please complete the following 4 slides of the survey. So that's all for today. Thank you very much for attending.
This concludes today's ISA web seminar. Please do not forget to fill out the evaluation survey found at the end of your presentation slides. Please fax the completed forms to ISA at 919-549-8288. Thank you for attending and have a nice day.